Hello, everyone, and welcome to this Microsoft Reactor session today. Before we begin with our session, I would just like to say a quick word about Microsoft's Code of Conduct. We are all here to learn, so I kindly ask you to be aware of each other and be welcoming and respectful to all points of views. Thank you. Here. I am going to now hand the word over to our speaker today, Chris. Hello, Chris. How are you?
Hi, Erica. I'm doing great.
Yeah, nice. Thank you. Thank you for being here. And I hand the word over to you, and then you can introduce you more about today's session. And we are now the 8th episode of this series, which is great. 2 more to go, but I'll let you do the talking. I'm here in the background if I'm needed. Okay.
Thank you, Erica. Hi, everyone. Good morning, good evening, good afternoon, depending on where you are. And welcome to the 8th session of Game of Learners. Today, we will be talking about Azure Cosmos DB. And this session is the second session about Cosmos DB. If you haven't checked out the first session, the video is available. I will share you the link in a moment. My name is Christopher. I'm an advocate for data at Microsoft. You can reach out to me on Twitter, and I will give you some links in a minute. And today I'm with Ismail, which is somewhere in the background. He's here for helping me to answer your questions. So you have a little chat box on YouTube. First, say hi, and if you want.
Sorry, we just lost Ismail. Oh no, he's coming back. I think he froze and then.
Sorry.
Yeah, back.
It's live. It's live. It's not recorded. Hello again, Ismail.
Hello. Yeah,
do you want to introduce yourself, Ismail?
Yeah, of course. Thank you. Well, I'm Ismail. I'm also a senior cloud advocate at Microsoft. I have been in some of the previous sessions. If you already saw, I presented the streaming one, and now I'm helping Chris with everyone in the chat with any questions or discussions. So great to be here.
And we are both joining you today from France. Do not hesitate in the chat window to say maybe your country, hello, and where do you join us today. So for this session, if you want to have access to the slides, to the recording, or to the demo code I will show you in a minute, there is just one link. It is that link. We will share it with you right now. So if you want any resource about that session, there is just one link. We will go over 2 Microsoft Learn modules together. You can just sit back, and relax, and then watch me going through the module, or you can join me and do the module with me. Is as you want. And again, this session is recorded, so you will be able to watch the entire session after the event. So as we said with Erica, this session is part of Game of Learners, which is a month long of content. We already done 7 sessions around Azure SQL. Ismail here, I've done the real-time analytics ones, and some of our colleagues have done the Azure Storage, and next week about Azure Synapse. And this week, I'm joining you to talk to you about Azure Cosmos DB with a first session where we explored the fundamentals of Cosmos DB. And today we will actually do some code and do real work with Cosmos DB. So there is a little, I would say, theoretical introduction, and then we will go right into the code. This series of events and series of sessions is a great way to get you prepped for the exam DP900, Microsoft Azure Data Fundamentals. And this month only, we are running an opportunity for you to get a free exam voucher. So you can go and register that link. Again, everything is shared on my website. I said it before, and I saw a few people starting to chat in the chat, but do not hesitate to discuss in the chat window and to ask any questions. Ismail, as I said, is here to answer them while I'm presenting. And from time to time, I will have a look at the chat window to answer some question for all of you here in video. With that, for today's modules, there is some prerequisites. You should be somewhat familiar with Microsoft Azure, we will go onto the Azure portal. We will use some Azure SDK. So you should have already an overview of what is it. And you should already have a very little knowledge about working with data or developing with a database, or even greater, having watched the first session from last Tuesday. If you haven't, you can stay here and always go back and watch the previous session as you want. For today, we will do a few things. The first one, we will talk about partitioning and everything related to partitioning, including logical and physical partitions and partition key. Partitioning is really important because this is the concept that allows us to scale indefinitely with Cosmos DB. So you need to be aware of a few things if you want to be able to deploy an application that can scale. And then we will go into the code and how do you use the Cosmos DB SDK from your code to create an Azure Cosmos DB database, but also create documents, query them, and do even some advanced things like store procedures and triggers. We will do all of this code demos in C#.NET, but there is other SDKs. So if you're, for example, Java developer or Node.js developer, the concepts are the same. The syntax is a little bit different, obviously, because it's a different language. So I would say let's get started right now. And you can join me on that link. Let me copy paste it into the chat if I can. I'm not sure I can, but probably some of my colleagues can do that. Again, you have the address just here. On this page, you will first see the session 1, which is Tuesday's session. And for tonight, we can jump right into session 2, Thursday, working with Cosmos DB. As I said, we will do 2 modules. First, we'll talk about partitioning, and we'll then do some real work with the Azure SDK. So let's get started with implement partitioning in Azure Cosmos DB. Let's skip the introduction. I've already done that. And let's explore partitions. So as you can see, there's a ton of text. We will go back to that text in a minute. But to introduce partitions, I wanted to use something which is more graphical and maybe more easier to grasp that reading 4 or 5 paragraphs of text. Is this drawing, and this drawing is actually part of what we call Cosmic Notes. And Cosmic Notes, you have the link here. It's a series of like sketch notes about Cosmos DB. There is a ton of great information here, distilled in a very simple, easy to understand one-pagers. So really interesting. Again, we have the link in my documentation. So let's go back to what is partitioning. Fact is, if you want to store, let's say, 2 gigabytes of data, you can store it into one single server, one single computer. This computer has enough power and enough storage to store 2 gigabytes of data. But if you want to store 20 terabytes of data, that starts to get complicated. And the more you want to store data, the more complicated it gets to store it into one single computer, one single server. That's why with distributed databases like Cosmos DB, we will actually split data over several physical servers, okay? And we try to do that in Cosmos DB in an intelligent way. That means that when you want to process a specific data or query a specific data, let's find a way to easily understand on which server this data is stored. For doing that, we will use what we call partitioning. Partitioning is quite simple in the concept. It's simply having a way to distribute your data into different buckets, and buckets that, in this case, you have some form of control. So you manage how many buckets of data we have by doing partitions. And how do you do partitions? You do it by creating a partition key. A partition key is very simple. It's just within a document, one property that contains some name. So, for example, let's imagine a to-do application, an application where you can just add the task you need to do for today, okay? Probably each time you will have access to an application, you just want to see your to-do. And Ismail probably don't want me to see his to-do because maybe he has some groceries he don't want to talk to me about or whatever. So in this case, finding the partition key is really, really easy. It's the user ID. So in this partition with the user ID Thomas, you can see you have 5 documents. On the opposite side, the user Andrew has also 5 documents. But for Deborah, we actually have 6 documents. All of this user ID, all of these partition keys actually create what we call a logical partition. A logical partition is not physical. We will see that in a minute. A logical partition is just a way to bucket different documents into the same group. And the relation between logical partition and where this data will be stored is actually an implementation detail. You don't have any control over it. And it's called the physical partition. The physical partition is the actual physical buckets where we store things. But it's quite complicated to get it right, and it depends on a ton of different factors. And we might have to move physical partition for like maintenance purposes because we have some server that gets down, or there is some partition that gets busy, and so we need to isolate them into its own computer. So that's why we offer you with Cosmos DB the choice of logical partitions. It simply is the value of the partition key, but you need to know that under the hood, there is a physical partition, and within one physical partition, you can have one or several logical partitions stored into the same physical partitions. Doing so, and if you choose your partition key appropriately, and that could be a challenge sometimes, we will see that in a minute, you will have infinite scale, because we in Azure, we can add more and more physical partition as you need, and we will distribute your load, and we will be able to scale horizontally. And when you scale horizontally, so adding new servers, you have practically no limit in terms of scalability. So that's basically what this whole text says. But I found it to be much more visual and much more clear when you just discovering this concept. I wanted to point out a few different things that are not mentioned in the comics notes and that are quite important to understand. The first one is even if you have a partition key, each document within Cosmos DB need to have an item ID. That's mandatory. So in any Cosmos DB document, you need to have at least one partition key and one item ID. And that item ID should be unique across the logical partition. You can have 2 item IDs within the same partition. And so if you want to access one specific document and really use the minimum amount of power, or for you who have already saw my talk last Tuesday, if you want to consume the minimum amount of RUs, resource units, you need to do what we call the point read. And for doing a point read, you need both the partition key and the item ID. And if you have both of these items where you are querying a document in Cosmos DB, you are just consuming 1 RU per kilobyte of data. So choosing a partition key is really an important decision that will affect a lot of different things. Your ability to scale, your application performance, the way you are querying data. So you need to get used to choose a partition key, and you need to read a lot of different things. Again, there is a lot of comic notes about choosing a partition key, and we will talk about that in more detail in a minute. But you need to take time. You need to think about your data pattern, usage patterns to really find the most appropriate partition key. One thing I wanted to add on the physical partitions, because it could be also important. There are some limitation on physical partitions. One physical partition can only go up to 10,000 RU per second, and to 60 gigabytes of data. That's a limit we have in the Cosmos DB service, so we're able to scale our services appropriately. So you need to ensure that within one physical partition that could contain at least one logical partition. So you need to ensure within one logical partition that you don't need to go over that limit. If you need to, then you will need to change the way you use, you decide your partition key, or maybe create what we call the synthetic partition key. And we will see what a synthetic partition key is in just a minute. So let's talk about choosing a partition key. A partition key has two different components, okay? And it's important to understand these two different components. The first one is the partition key path. Cosmos DB, in this case, we are talking about Cosmos DB for NoSQL. So you're storing JSON document, and you need to provide a path that is always here among all documents within a collection, okay? This logical, I didn't say that, it's quite obvious, but I need to say it. When we talk about logical partition, they are at the container level, not at the database level, okay? So you need to have some field that is here across all the documents within the same container. And then there is a partition key value, which is the actual value of a document, which means that when you, and we will see that in a few minutes, when you insert a document into Cosmos DB, you don't need to create another value. You just need to have this partition key within the document. And you will define, when you create a collection, you define the path, the JSON path of the partition key. Something that you need to consider when you're selecting your partition key, the value should not change, okay? So let's say you're creating a system for managing a school, okay? And you have the collection document with all of your students. The partition key could not be their current year. So let's say in France, for example, for high school, we go from the third class to the terminal class. We are going 3, 2, 1, and terminal is when you're getting graduated. You cannot have as a partition key third grade, because next year this key will change and the partition key will change, and we cannot move a document from one partition to another. If you want to do that, we need to delete a document and to recreate the document into a different partition. We need to have a high cardinality, which means if you're storing 2 million documents, you need to have a partition key that have a lot of different values. You cannot use a property that has like 2 or 3 values, because if you do that, it means that you will actually split your entire database into only 2 or 3 buckets, and you might hit one of the previous limits of physical partition I mentioned, 10K arrays or 5 gigabytes of data. And one thing which is quite difficult to achieve from the ground up is spread request unit consumption and data storage evenly across logical partition. For example, let's take a small application I've developed. I will show it to you in a minute. But is managing one of the process of the voting of the elections. Okay. Obviously, in France, we have a lot of small cities, but we also have some big cities like Paris. If you use a city name as a partition key, then you will have, I don't know, maybe 10x, 20x the number of records for the partition key Paris compared to a small city or a village. And by doing so, we will have what we call a hot partition, which is one or several partitions that are getting like 80% of the traffic. What we try to do is to have an even traffic across partitions. So in this case, you need to choose another partition key, or again, to create a synthetic partition key. That's the next page. So if you have another thing you need to consider is your read-write pattern in your application. If you have some large containers that are read-heavy, one of the ways to choose a partition key is to choose a partition key that appears very frequently as a filter. So, for example, if you're building a loyalty program for a chain of stores, and you have, I don't know, 5 different loyalty levels in your program, like bronze, gold, platinum, expert, and almost 90% of your queries are done with that filter, then maybe using that is an appropriate partition key. And last but not least, sometimes you just have an item ID, but you know that each time you will query that document, you will have that item ID. You will not need to do some search across all the properties of your document. In this case, let's just use the item ID as a partition key. And if doing so, if you have 1 million documents, you will have 1 million logical partition, but that's okay. Cosmos DB can handle a lot of different logical partitions. It would just store a lot of logical partitions per physical partitions, but you will get great performance by doing so. One of the things to consider when you're doing this is the item ID will become a unique identifier because, as I said a few minutes ago, partition key plus item ID needs to be something that is unique in the system. And one other thing to consider when you are using the item ID as a partition key is you can't run store procedures or triggers across multiple logical partitions. So if you need to do some store procedures to update other documents, by doing so, because each document will have its own logical partition, that means that you will not be able to create store procedure or triggers that will update other documents. Sometimes it's quite hard to choose a partition key. You need to do some trial and error. Choose the first partition key, try it with some code, with some queries, see what happens, rinse and repeat. Okay, that's, I would say, a normal process for some people who are just getting started on Cosmos DB. The other thing is sometimes it might be interesting to deduplicate the data. That is, having 2 collections that are storing the same data or almost the same data, but are using a different partition keys. Obviously, we need to keep the document in sync, but you have different things like triggers, like the Cosmos DB change feed to implement that. But sometimes it will be more efficient to duplicate the data than trying to have the perfect partition key for all your different needs within your application. So I talked a few times already about synthetic partition key. A synthetic partition key is simply a partition key that is created from different properties, from different values. Okay, so here we have an example in the IoT space. Cosmos DB could be used as a data store for IoT data. In this case, we are storing a document, and let's imagine, obviously, that this is not the complete document, and we have other properties like temperature, humidity, etc. And we have 2 fields. The first one is the device ID, the unique ID of the device in the system, and maybe a date of when this event or when this measurement has been done. What we can do, yes, we can use the device ID, but again, we only have 50 GB per partition, and some IoT devices can be chatty and maybe not immediately, not in a month or 2, but in 2 years, 3 years time frame, one specific device can reach that limit of 50 GB. In this case, using the device ID is not ideal. Using the date is not a good candidate as well, because using the date means that we will store all the data coming from all the same devices into the same partition. And we will probably hit the 50 gigabyte limit way before the end of the year. So in that case, we could create a synthetic partition key. So we add a field in our JSON document that will be a composition of two other values. In this case, we are combining the device ID and the date. And then, yes, having an IoT device that sends more than 50 gigabytes of data in a single year, it's maybe something that will not happen if you are dealing with a kind of a small IoT data. And if you are looking at some IoT devices that generate a lot of information, then imagine that the date here only has the year component, but you can add easily the months and day. And then suddenly, if you're using that partition key with device ID and year plus months plus date, you have 50 gigabytes of storage available per IoT device per day. And you have enough room to grow as you want. Sometimes we also use a random suffix just to generate a high cardinality. One of the issues of doing this is because it's a random suffix, you don't really know what is the partition key that has been used for storing a specific document. So it depends. It could have an interesting application in some cases, but you just need to be aware of your read patterns when doing that, because if you need to read across a specific partition or specific document, then using a random suffix might not be the appropriate one. Another way of using that is creating a synthetic partition key is pre-calculated suffixes. So, for example, if you're dealing with a car registration system, imagine that each item has a vehicle identification number. Then you can create some hash or some function that basically will transform a vehicle identification number into a fixed number of partition. So in that case, we are defining a hash that will return a value between 1 and 400. So we will split. It's what we call fixed partitions. We have a fixed number of logical partitions, and we are just creating a simple method that we input with a value, an ID, something, and that we output a value between 1 and, in this case, 400. But that way, you can almost each time evenly distribute the data you have. And it's easy to retrieve that data because you have that method of code. So when you are doing a search, when you want to query a document, you can pass on this ID to that method, and it will give you the partition key. So you can use that to do a point read. So that's it for the first module. So we are half in our session, and I will switch to the second module we will do today, work with Azure Cosmos DB. But just before, I have just quick look at the chat to see if there is any question I can answer, but I don't think so for now. So working with Azure Cosmos DB. What we'll do here is we will write actual code to interact with Azure Cosmos DB. So we'll skip the introduction. And as I said, for the session today, we will only use the Azure Cosmos DB .NET SDK, the V3. Beware, there is different version of the Cosmos DB SDK you can still find, but we are only talking about the V3, the latest version of the Cosmos DB SDK. Just so you know, the Azure Cosmos DB SDK is open source, so you can find it here, and you have a great link which you can find here in the Learn module that gets you to microsoft.azure.cosmosdb.samples directory, where you can find a lot of different samples for doing batch geospatial queries, custom serialization, container management, change feed, etc., etc. So it's a great way to discover more advanced feature of the Azure .NET Cosmos DB SDK. If you are not a .NET developer, if you are a Java developer, Node.js developer, Python developer, there is also an SDK, Cosmos DB SDK for you. And if not, do remember from my first session of the week on Tuesday that Azure Cosmos DB is, I would say, polyglot. It can talk Apache Gremlin API, can talk Apache Cassandra API, or MongoDB API. So if you are using, I don't know, Ruby, because you're developing a Ruby on Rails application, you are used to store your data into MongoDB, you can use your actual code and your actual SDK to talk to Azure Cosmos DB for MongoDB. So let's go back to the Microsoft.NET SDK. What you have here on this page is a list of samples on how do you use the Azure Cosmos SDK. Obviously, you will need to first to add the Microsoft.azure.cosmos NuGet package to your project. And once you have done that, you can start by creating a Cosmos client object. The Cosmos client object will need two different parameters. The first one is the endpoint of the Cosmos DB account, and the second one is primary key. So if you want to have these two items, you have several options. You can go into the Azure portal and create a new Cosmos DB account. And we have a free tier on Cosmos DB, so you can create a free Cosmos DB account. There is also aka.ms. Oh, no, let me show. I'll put the link here. Just on the beginning, you have Try Cosmos DB for free, aka.ms/trycosmos, where you can create a free Cosmos DB database for a month, for 30 days. So I've already done that before the session. And when you've done that, you stumble upon this page. So I have only 26 days left in that free account. And when you click on Open the portal, you're going into the Azure portal, and you don't need to have neither an existing Azure subscription nor using a credit card to get that running. You just need Microsoft Live, Microsoft Xbox account. That's it. So that's a really great way to get started with Cosmos DB. Last but not least, you can install the Azure Cosmos DB emulator. Again, if we go back here, you have the link to the Cosmos DB emulator that allows you to simulate Cosmos DB on your own laptop. So you can even create application with Cosmos DB while being on an airplane or train without an internet connection. So that's the first thing you need to do. For anything you want to do on Cosmos DB, you need to create a Cosmos client. Then the next thing you need to create, and let me go here on my Cosmos DB account on Data Explorer. When you have just created your Cosmos DB account, it's kind of empty, and you need to create first a database, and then within that database, you need to create a new container. And you can do this here right within the Azure portal. You can do it with infrastructure as code, either using Bicep or Terraform, or if you prefer, you can do it with code. And that's exactly what we are doing in this example. You can coding on the Cosmos client method, the create database if not exist a sync with a database ID and the number of request units you want to provision for that specific data. You can read and delete the database as well. When you have done that, you can create a container quite easily again. This time on calling the create container if not exist a sync method on the database object. And for creating a container, as I said before, you need a container ID, or if you prefer a container name, you need a throughput, so the maximum amount of RU of request units you want to handle, and you will need a path to the partition key. Remember what I said like 10 minutes ago? A partition key has two values. The partition key path, that's what you want to set up here, and the partition ID value, that's something each document will have. So you're not always creating new containers. Most of the code you will be executing, there will already be a container existing in your database. So in that case, you can just do a get container, passing the container ID, and that's it. You can then get a container object that you can use to add item on it, query the container for documents, etc., etc. Let's go to the item, so the documents. When you want to add a new document into Cosmos DB, you create an object in .NET Word, okay? In this case, a sales order, and you just have to do container.create item async. You need to pass on the object you want to create, and also the value of the partition key. That is used so the Cosmos DB SDK and the Cosmos DB service knows to which physical partition this document should be stored, and then it accelerates the process and accelerates the performance of storing the data right into the physical partition without having to do some lookup, without having to ask a specific service, hey, I have this document I want to store, which server contains that physical partition. That's why we need to pass on the partition key when we create an item. If you want to read an item, in this case, we are doing what we call the point read, which means we are tapping into the right partition and picking up just one document. So it's very easy, container.read item async, passing on the document ID and also the value of the partition key. We can query an item by doing a SQL query. So here we are getting all the documents where the account number is of a specific value. And this here, as you can see with the @ sign, we are using a parameter. So there is no SQL injection possible. And we define the value of the parameter with the with parameter method. And then we get something that is called a feed iterator. This is done only because you might have a huge number of documents, and there is a ton of reasons for not collecting all the documents at once. So what you can do is collecting document by pages, so only 1 by 1 in this case, or 10 by 10, and then you can ask the browser set, is there any other documents I can get, and then get the other documents as well. So if you go to the exercise page, you can do things on your own. You can follow this code. You will need a bunch of different things. You will need Visual Studio Code or Visual Studio. You will need to have .NET at least .NET 6, but it works with .NET 7, which has just been shipped a few days ago. If you are using Visual Studio Code, you can use the C# extension. Yes, you can do all of this, but I find it a little bit complicated just to discover the SDK. So I'm using something else, and I will show you in a second. I will actually use a notebook, a C# .NET interactive notebook. For that, you will need just VS Code, .NET, and the VS Code Polyglot Notebooks extensions. And when you are doing that, you can let me open here my Visual Studio Code, zoom in a little bit. You can have a notebook. If you're doing some data work or data science work, you're already familiar with notebooks. Notebooks is simply a way to organize both documentation in form of Markdown and blocks of code, and you can execute these blocks of code one by one, and everything you execute in one block will be available in the subsequent blocks. So what I've done here, and I will go over that code with you in a second, I've just copy-pasted the code you have here. So if you follow along with the Learn module, you will create an executable, a console application. I've just copy-pasted that code and slightly modified it to get it working with the notebooks. If you want to follow along with the notebook, you can download it here. You will have access to the exact same notebook. The only thing different is within my notebook, I've used here my Azure Cosmos DB endpoint URI. And here you can see just the beginning of my primary key. And if you download the notebook, you will have to input your own endpoint and primary key. That's it. So first thing to do is to import the NuGet package that's done here. Here we will just create the Cosmos client. It will be very easy. Here it's a method to create a container and to create a database. And this is like a method to call both create a database and then create a container. And here we will start to do interesting things. So let me switch back very quickly to my Azure portal. And as you can see, I have no database, no container. I will execute that code. And hopefully, database has been created, container has been created. If I go back here, you can see my database has been created now, and my container has been created as well. And if we go to scale and settings, you can see here that I choose as a partition key last name. So every document I store in that collection need to have a last name property. So let's add some items. For that, I've just creating a class or a record, to be exact, person with first name, last name, city, and an ID. And I'm creating myself, and I will call the Cosmos DB container object from the Cosmos DB SDK, the create item async method. And as you can see, I get a result out of calling that method, and we will see this result in a second. Something that is quite interesting in that result, and you might want to use it. As you can see, there is a ton of traces where my data is stored. So here, my Cosmos DB instance is stored in East US2, and I'm based in France. So I'm calling a database in the other side of the ocean. So it's not an optimal solution, but it's a free solution. So that's OK. But here, there is a property request charge, which contains the number of request units that has been consumed to execute that query. So that's something when you are developing a new Cosmos DB database that you need to look after to ensure that you're minimizing the number of request units. If you don't have a small number here, that means that maybe you can optimize something like changing the partition key or doing a different query. So I've just created one item for now. Let's create a few other family members and also Ismail in the database. And let's bulk insert all of these items. So I should have now 4 items in my database. So let's create a query to get these ones, where I will try to filter them by last name and only taking myself. So we should have 3 items here. Let's try it. And yes, there is only 3 users because I have 4 documents. Let's switch back to the Azure portal. If I go to the items page, you can see I have 4 documents, but only 3 of them are Manu, and Ismail is right here in the middle of the other member of my family. So as you can see, doing a query is quite easy over Cosmos DB. The only thing that is a little bit more complicated than what I say the traditional database is that feed iterator. But as you can see, I just need to do a do while read next async results, while there is still more results to collect from the result set. And doing so allows you to batch get the different records. And if you have 1 million documents, you don't have a long running query that will try to transfer, I don't know, megabytes or maybe gigabytes of data from the database to your code. You can do it in small chunks and even start to send response back to the user, back to the client, the web APIs, the mobile, etc. Or you can easily build paginations with tools like this. So really useful and can scale to an infinite number of results. So let's go back to the module here. One small note that is important in that module, if you follow along, it will ask you to log into Azure to create a resource group, to create a Cosmos DB database. If you're doing so, it will cost you some money on your subscription. So if you are using that at the end, please do not forget to delete your resources. Obviously, we explain it to you how to delete all the resources in the Azure module, but that's something important if you're using your own subscription. Or, as I said, you can use Try Cosmos DB to use a free database for that exercise as well. So let me check if there is any question in the chat. I think Ismail has answered to all of them. So create store procedures. In Cosmos DB, you can do a bunch of different things, including creating store procedures and triggers, both pre-saving trigger and post-saving triggers. That could be really useful in several cases when you want to populate a specific field within the database, or want to, if you want to keep in sync different documents. So let's say you store in the same partition different documents that have some links between them. So when one specific document is updated, you need to update other documents in the same partitions. If you want to do it automatically, you can create a trigger for that. You can also create user-defined functions to compute some things, and then use these user-defined functions, for example, from SQL queries. That's also one thing you can do within Cosmos DB. So let's focus on store procedure for now. Writing store procedures is done through writing a small bit of JSON. So you have all the documentation to understand what you can do within store procedures, but when the code is already written, you can create a new store procedure right from the Azure portal. That's what we'll do here. You have a sample code here, or you can also use some code. So it's not here, but if you go on that documentation page, you will see with the .NET SDK how you can create a store procedure from code. So in this example, I'm storing my store procedure JavaScript code into a file along with my C# code, and I'm calling my C# code to upload and to install that store procedure within my Cosmos DB account. For tonight or today, depending on your time, we will do it from the Azure portal. So if I switch back to my little notebook here, I will create a store procedure named createPerson. The name is important. We will see that just in a minute. And I will copy paste that sample code, which is the exact same, by the way. It's the exact same code that we get here. I just this is a JavaScript Node.js sample, so I just extract the body of the store procedure, and that store procedure is really simple. It's getting the current collection where you are coding from the store procedure, and it asks the collection to create a new document using the document that has been passed into parameters of that store procedure. So it's stupid. We don't need that code in production because we just can code create item async. But in this case, just to show you how to create a new document from a store procedure. So I'll copy paste my code and I will save it. Yep, up. And I just double check the name, create person. Yeah. So it can take a few seconds to actually create the store procedures because, as I said, Cosmos DB is a distributed database, so there is several servers that actually contain and execute your database code, and we need to replicate that store procedure code across all these servers. So it's done now, and I will use a different approach where I get the container and I will execute the store procedure by calling the name, a partition key, and by passing the arguments. In this case, I only have one argument, which is the document I want to create. So let's try this. It has been created. As you can see, the status code is OK. And if I go back, so it's Julia Manu. And if I go back to the list of items and I refresh, I should see a new document, Julia Manu. So that document has been created through the store procedure. And we can query it again here, and we can see Julia has been added there. Last thing I wanted to show you is how to create triggers. So as I said, triggers are useful to update documents, to keep documents in sync within the same partition. The way you create them is exactly the same the way you create a store procedure. You can do it from the Azure portal. Let's do that. And you can also do it from code. When you create a trigger, you still need a name. So validate timestamp. You need to define if it's a pre-operation trigger or post-operation trigger, so pre-delete or pre-insert or post-delete or post-insert type. And you need to specify if it applies to only a specific operation, create, delete, or replace, or if it can be used to all type of operation. Let's say all in that case. And let me paste that code. So this function is doing something that is very, very simple. It verifies, it checks if the document I'm inserting has a timestamp property, and if it hasn't a timestamp property, it adds a timestamp property before we save the document. So if we go to my item list, as you can see, there is no timestamp property. Here, there's no timestamp property. However, if I go back to my code and I use a create item async and I display the item, it has been created. And if I refresh, I have a new document, Cassandra, and here I have my timestamp property that has been added by the pre-trigger. There is one thing you need to be aware that is quite different from the other databases systems is in most other databases out of Cosmos DB, you don't need to do anything special. When you register, when you save the trigger, it applies the next time someone is doing the operation. Within Cosmos DB, each time you want to execute a pre-trigger or post-trigger, you need to explicitly say to Cosmos DB, hey, I have a pre-trigger that has this name. I want you to execute it before doing the operation. And that's something you can do quite easily with, for example, the create item async function by just passing a new item request option argument with a list of the pre-triggers you want to execute. So it's very powerful, but it's somewhat slightly different from your other databases you might use. And so that's something you need to be aware of. And that's it. We're almost at the end. Let me double check here. Yeah, I just wanted to show you, for example, an example of user-defined functions. Here I'm storing users with their income, and I want to compute the tax automatically, for example, while doing a query. And then you can create these small JavaScript functions, and then I will be able to do something like select like where tax is above a certain limit. One last thing I wanted to show you before going back to slides and seeing if you have any questions is proxy vote. What I show you today is very small code samples, but if you go on my global link on proxy vote GitHub, you will stumble upon a project I've developed, which is an end-to-end demo of how can you use Cosmos DB in a real-world application. Proxy vote is doing proxy voting registration system, and it can handle 1 million users in less than 2 hours for less than €5 total in Azure consumptions. So you can go here, add all the code, and I will also add a video I've done with the Cosmos DB team explaining the detail of proxy vote and how I've can develop, choose my partition key, create some analytics on top of that very easily thanks to Cosmos DB and Azure services. So we are already at the end of our session today. Again, all the links, all the documentation, all the code is available on that link. So do not hesitate to check out these resources. As I said in the introduction, you can get access by following this Game of Learner series to a free voucher for the DP900 Azure Fundamentals exam. I hope you enjoy the presentation today, and I will just switch to my other screen to see if you have any questions. We have 1 or 2 minutes, so do not hesitate to ask any question in the chat. So I don't seem to have any specific questions. Ismail, if you want to join me again to say goodbye, do not hesitate. And for you who are watching the video, thank you for attending that session. Do not hesitate to ask any questions in the comments in the YouTube video. Even if you're watching this video in replay, we'll try to watch the comments for a few weeks to see if we can answer anything. Or you can join me on Twitter. You have my Twitter account here. Hello again, Ismail.
Hey, hi. Pretty great presentation. Thank you. It was really nice and really well received in the chat. So congrats for that. Cool. I don't think there are more questions. I think, well, if anyone wants to dig deeper, well, there is definitely a ton of content out there at Microsoft about Cosmos DB. So just dive in.
Yeah, you have a ton of Microsoft Learn modules. We obviously have our documentation that go into details about scalability, throughput, and a ton of other topics within Cosmos DB. There is also the Cosmic Notes I showed you earlier in the presentation that are a great resource to discover Cosmos DB in a, I would say, lightweight way or graphical way. So do not hesitate to check out these resources.
Yeah, and don't forget to continue, well, the Game of Learners. There is still 1 more week to go, so see you next week, maybe with Josh.
Yeah, thank you all for attending, and see you next week on other Game of Learners sessions.
Okay.